Today let's start with hydrocarbons, carbon and its compounds of standard 10th. So why we call them as hydrocarbons? As the compounds are made up of carbon and hydrogen, so we call them hydrocarbon. Now hydrocarbons are of two categories. They are saturated hydrocarbons and unsaturated hydrocarbons. If there is single bond between carbon and carbon atom, so as I told, they are made up of mostly carbon and hydrogen. So if there is single bond between carbon and carbon, we call it as saturated hydrocarbon. If there is double bond or triple bond, we call it as unsaturated hydrocarbon. Now coming to the general formula, for saturated hydrocarbon, general formula is CnH2n plus 2, where N stands for number of carbon. For alkene, it is CnH2n, and for alkyne, it is CnH2n minus 2. Alkane, An is there representing single bond. For alkene, if En is there, represents double bond. And if Yn is there, alkyne, it represents triple bond. Now here, depending on the number of carbon atom, different prefix are used. If suppose one carbon is there, we call it as meth derivative. For 2, eth. For 3, prop. For 4, but. For 5, pent. For 6, hex. For 7, hept. Then we add the suffix ane if single bond is there between carbon-carbon. If there is double bond, we add ene. If there is triple bond, we add ine. So the complete name for single bond, one carbon, it will be methane. Methane is the only member where single bond is there. There are no double bond and triple bond derivatives, because for double and triple bond, at least 2 carbons are needed. But in methane, only one carbon is there. So this is one of the important topic you need to remember. Now coming to the structure, how we are going to write them. If suppose it is methane, we need to remember like carbon is having valency 4. So we need to satisfy its 4 valency. That if we are satisfying with hydrogen as their hydrocarbons, we call it as meth, depending on carbon, meth, and as all single bonds are there, ane. Now if suppose double bond is there, first we need to count out number of carbon. So here 2 carbons are there, so we call it as eth. Then next we need to balance out with valencies. Here 2 carbon are there, 2 bonds are there, so we'll make it 4. Count and make 4. So now it has got 4 bonds. So this rest we satisfy with hydrogen. Already 2 got satisfied with carbon. So rest 4 we are satisfying with hydrogen. 2 carbon are there, so we call it as eth, ane, and then double bond is there. So we'll replace this with eth, ene. Now coming to triple bond. If there is triple bond, we call it as ine. As double bond, 2 carbons are there, so we use the word eth for the triple bond. Yne is used. Now we need to balance out again 4. So already 3 hydrogen is there. So 3 bonds are there. So we'll add one more hydrogen both the sides to make it 4. Depending on number of carbons, the name is given. So it's very easy. If suppose they will ask like to draw the structure of butane. So first we need to see out like how the number of carbon is given. As it is but, so here 4 carbons will come. Now count out the bonds. Already one bond is there. We need to add 3 bonds. So here it will be hydrogen. Here already 2 bonds are there. So 2 more hydrogen. Again 2 bonds. 2 more hydrogen. Here 1 bond is there. 3 more hydrogen. So thus we got the structure of butane. So it's very simple. You can easily learn out. Students, let's start with functional group. So this video today I am preparing on behalf of my one of the oldest favorite student from Bharampur. So she demanded for having some more videos with carbon and its compounds. So this is the first basic which we need to learn from this chapter. So let's start out with functional groups. So here the first functional group is alcohol, where we add the OH functional group, and suffix added for this is ol. So as all of you know, while writing the names of the carbon compound, if they are single bonded compound with one carbon, the name is meth, and then we add ane in the last. So here For alcohol, we remove this E and we add ol. Whenever alcohol is added, we add the suffix ol by replacing E from the name. So as I told, it is a single carbon compound. So here CH3 OH is attached. Now for ketone, I already explained difference between ketone and aldehyde. So here we are starting with aldehyde first. So aldehyde, there is an attachment of C double bond O H group. And I told you that here the carbon must be the last carbon. And we add suffix al. So as again the methane is there, the first member, replacing E with al. So for aldehyde, we call it as methanal. And formula is HCHO, where CHO is functional group. Now coming to ketones. Ketone, the first member will have 3 carbons at least. So this is a very important point, don't get confused. The first member of this derivative is 3 carbon compound, where we are having the same structure like aldehyde, and here the suffix -one is added. As the first member is having 3 carbon, so the name is given prop, and then ane is replaced by one. For 3 carbon prop, and then E replaced by one. And the structure is 3 carbon with double bond O for ketone. Now coming to carboxylic acid. So here functional group is C double bond O OH. Here the suffix oic is added, oic acid. As again the first member is methane, we replace E with oic acid. So the name is methanoic acid. And its formula is HCOOH. COOH is attached at the end of the formula. Now coming to halogens. To halogens, chlorine, fluorine, bromine and iodine belongs, which we represent by X. So here R is representing some alkyl group. It can be methyl, that is if 1 carbon, ethyl if 2 carbons are there, propyl for 3 carbons, and whatever halogen we are adding out of these. Here we add IDE as a suffix. So here if 1 carbon is there, as I told, we'll be using methyl, and then I added chlorine, so it is methyl chloride. IDE is added. Okay. So here we need to add IDE. Now coming to ester. Ester derivative represented by R dash C double bond O. So one of the side I represented R and other side R dash. So these are representing different alkyl groups. So for example, it can be CH3, it can be C2H5, so on. For esters, we use the suffix ester only. Here I have taken the example of CH3 on both the side. So the name will be dimethyl ester. As methyl derivative is there 2 times, so we call it as dimethyl ester, or we can call it as methyl acetate. CH3COOH is called acetate, so we can call it as methyl acetate also. Hope everyone understood it.